Hey everybody, this is Larry. This is me doing week 3 of the weekly premium challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. 2832, have I done it yet? Oh, nice. I'm always excited when I see a new problem, so today I'm excited. So let's take a look. Today we have 2832, maximum range that each element is maximum in it. What a... These naming is a little bit wonky, but okay. I mean, I take it. Let's actually read the poem. I don't know, sorry, I'm having a little fun sometimes. You're given a zero index array nums of distinct integers. Okay, let's define a zero index array ends of the same length as nums in the following way. N sub I is the maximum length of a subarray left to right, such that the maximum element in that subarray is equal to num sub I. Return the array ends. Note that a subarray is a contiguous part of the array. Okay. What's going on? Maximum length of the subarray such that the maximum in that maximum element of that subarray is num sub 1. Okay, 1 is just 1 by itself. Okay. 5 is the maximum. Oh, this is 6. I didn't know this is 6. Okay, 0 to 4. Okay. 4 is going to be just 3, 4. Okay. 3 is just 1. Okay. And then 6 is, and they're all unique, so there's only they're only located in one place. Okay. The n is pretty big, the number of I is pretty big, but they're all distinct. So I guess just to kind of say that, like, it's not, you can't use an n square algorithm. I guess that's what I'm trying to make sure is real. So okay. So trying to think, right? I think there are two ways to for me to attack this from. One is kind of the sliding window idea. The other is kind of maybe breadth first search right? Or not even breadth. I don't know if breadth first search is the right idea, or like union find. Sorry, I mean you can probably do union find, or sorry, you can probably do breadth first search as well as part of the union find. Or like the same idea with connectivity, but I think union find is actually a good idea for this problem, even though maybe there's a sliding window. So if I remember, I'll look at the solution to just kind of see. I mean, I think there may be a sliding window, like we can probably do it with sliding window, honestly, but I feel like union find is just way more cleaner in my head. And the idea is this idea of greedy, right? So if we go and this kind of goes into I did a very long video problem on day 14 of the Leetcode daily challenge. This one, right? So if you Google for it or YouTube for it, for this video on, I talk about invariants and stuff like that. So I spent, maybe I need to separate out another video, but I did spend a good time working on that video. So definitely, you know, I don't want to repeat everything because I'm a little bit tired today. But yeah, but that's basically talking about invariants, right? And what I want to talk about invariants with respect to this problem is this invariant about, or this idea of reusing work based on these invariants, right? And if we are able to kind of enumerate nums in the process nums in the way from smallest to largest, for example, then now, let's say you have a number 10, right? That means that the invariant is that you already process 1, 2, 3, 4, 5, 6, 7, 8, and 9, or whatever the smaller numbers are, right? And as a result, that means that if 10 combines with something that's one of the numbers or smaller, then you know that it already extends to that item. So that's really the idea. So union find is kind of always tricky to kind of describe in my style of videos. What I mean is like having a daily problem. You know, obviously I cannot just do like a union find video every time, because that's just like not a good use of my time, and maybe not even good use of your time, depending on where you are. So definitely make sure you understand union find at least at a very basic level, or at the very least at a level where you can use it as an API, right, as a library. So okay, so I'm going to write that parents is equal to I for I in range of n, right? this is just me going doing union find things. I'm not going to go over it that detailed in terms of what I'm writing right now, just because yeah, this is union find stuff is what I mean. Right, and yeah, I guess I have templates for this, but yeah, right, but in any case, right, so sorry, let me just crank this out. Right, so then now we have these two functions with this is enough for the union find, and now we can just, well, do the union find, right? So what do I mean by looking for these invariants and solving problems in a way? And I kind of talked about it, or mentioned it anyway. I don't know if I talked about it in detail, which is processing numbers from small to largest. As I said, then now you can reuse all the previous calculations that you've already done. So then, because you already reused the work that you've already done, then you don't have to do it again, right? So that's kind of the idea about putting off these invariants of things that you've already done. Okay, right? So yeah. So then now we want to say indexes is equal to, say, I don't know, whatever, right? So then now for index x in enumerate nums, right? We just want to say indexes dot append. We want to sort by the x, but also keep track of the index. Maybe this could have been done another way, actually, honestly, but whatever, I don't know. Just want to sort, right? And then now we can say for and we don't even actually care about the number, we just care about the index, right? In indexes, right? And then now we process the index in nums, because now we know that this is the current number is the smallest number that we're going to process, and we process it by I think maybe this part I wasn't too clear about, but I mean I had it in my head, but there's some like minor implementation details, which means that maybe this is just like maybe done is equal to force times n for the indexes, right? So here well, done of index is going to be true, just because this is the only time we set it to true. And then now we go yeah, for I in index -1, index +1, so basically two adjacent indexes, if they're also done, then now we can union them combined, right? Union I and index, that's actually kind of confusing, but that's fine, right? Actually, I kind of missed. I kind of did the union find too quickly, and I forgot some parts about it. But for this one, we need to use the size version in a way that we'll see in a sec, right? But yeah, but that's basically the structure of it. I would just want to go over. The reason why is because then now, let's say you're processing 1, then 1 is going to be by itself, 3 is going to be by itself, 4 is going to be merged with 3, because 3, and we know that, and actually done is maybe not even necessary. I think this is why I was thinking about it earlier, but okay, maybe we don't need done, because there's an implicit way of writing it, but I kind of just forgot, I suppose, honestly. And also, I wrote it this way so that I could check on bounds, but then I just also forgot. So very sloppy things, honestly. But yeah, and num sub index is greater than num sub I, right? Because if this is greater than, that means that number is done, so then we can union them, right? And the idea here is that we go back to here on the example. I'm probably pointing the wrong way anyway, but pointing the example, if we do 4, because 4 is bigger than 3, and we know that 3 is already processed, so we're going to just add it to that component, and that'll just make it, you know, and the so there are a couple of invariants there, right? One is that all the numbers smaller than whatever number we're processing is done. We mentioned this a few times, but the other thing is that the component size of, or like all the unions, all the different component unions, they are all subarrays, right? Because you can only extend left, you can only extend right, or left or right. Like you can't jump around kind of unions. That means that everything's gonna be subarray, so then the size represents the size that we're looking for. That's pretty much the idea. That's pretty much it. We have to fill in some details. I'm going to do the apparently I'm doing it in the most crazy way that I can, because I don't know why I'm doing it this way. But yeah, and then answer is index is equal to, let's just say use size of index, right? I mean, I guess technically it doesn't matter which one, but yeah, and here we just need to kind of keep track of size, right? I guess I don't know why I wrote it this way. I mean, yeah, okay. I mean, these are values, so that's why it doesn't matter, right? And then you find union, and all that changes is that, yeah, if UA is equal to UB, we just return. Otherwise, and then the size of UB, we add it to the size of UA, right? And then the U size of X, which is just equal to U find of X, and then that's it. And yeah, and that should be good. Yeah. If it was right, it should be good. What? Dong dong dong. Do I not process these, or why am I getting no's? I mean, clearly I don't process the ones, but why do I not process the ones? Oh, because of this thing. I'm just being dumb. Because this should be outside the for loop, because if you're yeah, I'm just being dumb. All right, let's give a quick submit. Hopefully I didn't make a silly mistake. And yeah, there you go. It's slower than a lot of people's. I assume that there's an easy way to do it, but I think the or like maybe there's a more direct algorithm. Maybe you don't need union find, honestly. Maybe the way that you kind of merge, and because you always merge left and you always merge right, union find is probably the heaviest way to do it. And I do need a sorting thing, so maybe that's why it's a little bit slower. But I think the reason, sometimes if you know an answer is right, it just comes down to, like, you know, where you want to go. Yeah, I mean, I don't feel that bad about it, but I am curious whether there is a sliding window one. Oh, there's a mono stack? Huh. I hate the term mono stack though, but I don't know. I mean, I guess that makes sense. The idea would fit with a lot of stuff, but I don't know. For this one, I find this the union find solution more intuitive. But yeah, anyway, yeah, that's all I have for this one. Let me know what you think. This is dominated by the indexes sort. Yeah, that's all I have for this one though. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy, to your mental health. I'll see y'all later and take care. Bye bye.